Hi everyone, I am Mayank Savarkar and my team member name is Anuj Oja. Currently we are studying in third year in sixth sem and pursuing in BTech in Electronics and Communication from Malwa Institute of Technology, Indore. Today I am here to present my internship project washing machine simulator using PIC 6F877A in microcontroller.
C programming language. So C was created by Dennis Ritchie at the Bell Laboratories in 1972 as a system implementation language for the Unix operating system. It is a very popular language. Despite being old, is simple and flexible programming language that is widely used in various applications. Its characteristics include it's a general purpose language, it's a free formatted language, it's highly efficient, and its portability to different operating systems and situations and its library facilities. These characteristics distinguish C programming from other languages which came thereafter. So let's see about basic data types in C. It includes the basic distinguishes is integral value and a float point data type. So in integral data type, there are two specific data types, which is integer and character. Character is used to store single characters. It typically occupies 1 byte of memory. Integer data type is used to store integer values. It typically occupies 4 bytes of memory on most systems. Floating point. With respect to floating point, we have two data types, float and double. Float is used to store floating point numbers. It typically occupies 4 bytes and provides single precision floating point representation. Whereas double is used to store double precision floating point numbers with higher precision compared to float. It typically occupies 8 bytes of our memory. Okay, let's look at the modifiers and see. There are 5 types of modifiers, which include short, which stores 2 bytes of memory, which takes 2 bytes of memory. Long stores 4 or 8 bytes of memory. Long stores 8 or 16 bytes of memory. Signed stores both negative and positive numbers. Unsigned stores only positive numbers. With respect to signed, in case if it's a character, the entire memory allocation of characters are a 1 byte. In case of signed, it is split into both, and half is given to the negative and the other half is given to the positive. Conditional constructs in C. As the name implies, conditional constructs follow a block of code or implement a block of code with respect to the condition, whether it's true or false. So that we can broadly classify the conditional constructs with respect to the number of iterations they undergo. So they can be single iteration or they can be multi-iteration. With respect to single iteration, there are if statement, if else statement, if else if statement, nested if, and switch case. In if statement, will be given an condition, and if the condition is true, it executes the block of code inside if statement. Else, it just goes to the next line of the code. With respect to if else statement, there is a condition given for if that is satisfied, it executes this block of code under if not, it goes for the else statement, else block code, and it executes the else block and then comes out of the conditional construct. In if else if statement, there are two conditions. There is a condition with respect to if, and there is a condition with respect to else if. And with respect to nested if, there is an if condition inside an if condition. So when there are multiple conditions that are to be checked, and that too with respect to single condition, like for example, uh, if you want to check whether a person is both, what to say, like if he's a voter, and then in turn we have to check whether this guy is above 40 or below 40, then we'll have an if condition at the beginning whether his age is greater than 18 or not, and then inside if condition again we'll have an if conditions checking whether he's above 80 or less than 80. So that's with respect to nested if. And switch case is used when there are multiple if conditions, like case in order to be executed. And with respect to switch case, we have a default case. In case if none of the cases are satisfied, then it defaultly executes the default block code, and we have to use break statement at the end of every case present within the switch case. in order to make sure that only a single case is executed and not all of the rest of the cases. And conditional constructs with multi-iteration includes for, while, do while. With respect to for, there is an initialization, there is a condition, and then increment or decrement. This increment or decrement can be given in either in the for loop bracket or inside the loop too. But the syntax should have two semicolons within the for loop brackets and while loop. And for loop is executed until the condition is false. Same with respect to while loop. There is inside a while loop we check for condition, we go for the execution of code until the condition is false. Whereas in while loop, the incrementation or decrementation should be inside the loop. With respect to do while loop, first the code is executed once and it is checked for whether the condition is true. If the condition is true, it goes for the second iteration, third iteration until the condition is false. In do while 2, there is increment or decrement of an initialized variable is done inside the loop. So operators in C. Operators in C includes arithmetic operators, which includes addition, subtraction, division, multiplication, modulo operator. Modulo operator gives remainder, and division operator gives quotient. Relational operators include less than equal to, greater than equal to, and checking if they are equal, and checking if they are not equal. And logical operators like and, or, not also exist. Pre and post increment operators, these are widely used in for loops, while loops, in order to increment or decrement a variable, pre and post increment. And bitwise operators includes and, or, left shift, right shift, etc. Assignment operators includes equal to, plus equal to implies that you add an constant with respect to a variable. For example, I plus equal to r is nothing but I equals I plus r. And then same with respect to subtraction, multiplication, division, and modulo. Other operators include ternary operator, takes three operands or variables. It is a way to shorten the simple if-else code of the block. Yeah, which reduces the number of lines, thereby reducing our runtime, etc. Arrays in C. So an array is nothing but it's a user-derived data type. Array is a collection of data of same data type. It cannot have two different datas of two different data type. So first element will be with the lowest address and the last element with the highest address. Each element in the array is accessed by index, and with respect to array, they are, as you can see in the image, it is a contiguous memory allocation. Here we have stored an integer array. We have created an integer array, which means integer takes around 4 bytes of memory. So the second element is stored in the address, which is incremented by 4 bytes from the base address of the index first element. So so we can see that for the first element takes base address, then plus 4 for the second one, then plus 8 for the uh, third one with respect to the first one. So this is contiguous memory allocation. Strings in C. String is a contiguous sequence of characters, set of things tied or threaded together on a tin cord. End of the string is marked with special character called the null character. This is useful when you try to iterate and then in order to know that you have reached the end of the string while iterating through it. This is useful. Memory will be allocated also for null. The difference between a character array and a string is that string is terminated with a unique character. Pointers in C. Pointers are used to store the address of a variable or a memory location, and the type of the pointer is the type of the variable that it's going to point. For example, if you want to point an integer variable, then your pointer should be of a type integer. We can access and manipulate the data stored in that memory location using pointers. As the pointers store the memory addresses, their size is independent of the type of data they are pointing to. We add an ampersand to the variable in order to store the address in a pointer. We add an asterisk star mark to pointer to extract the value of variable it is pointing to. As you can see, they have created an variable x and then an integer type pointer since it's going to point x, which is an integer type, and we have initialized the x and then we have stored the address of x in pointer. In case if we use dereferencing thing, we'll get the value of x. We can retry the value of x from the pointer. Functions in C. A function is a set of instructions which are set to perform a specific task. Functions can be stored in a library and reused. When some specific code is to be used more than once at different places, function avoids repetition of the code, thereby reducing the number of lines and then also reducing the runtime and increasing the efficiency of the code. A function can have three parameters: input, operation, and output. For every function we call, there will be a stack that is created. After the function is executed, the stack will be destroyed. We have two methods of parameters passing. Pass by value. Changes made to the parameter inside the function has no effect to the actual argument. Then it's called as pass by value. With respect to pass by reference, changes made to the parameter affect the argument. So the rest will be, so the embedded systems will be continued by Gokul Krishnan.
Hello everyone, I am Gokul Krishnan from SSN College of Engineering. Now we see about what is embedded system and its types, and also see the component in embedded system. What is embedded system? Embedded system is the combination of computer hardware and software designed for a specific function or task. Embedded system may also function within a larger system. The system can be programmable or have a fixed functionality. Examples of embedded system used in industrial machines, consumer electronics, agricultural and processing, industrial devices, automobiles, digital watches, airplanes, vending machines and toys, as well as mobile devices are possible locations for an embedded system. Embedded system play a crucial role in aerospace and defense system also. They provide essential functionality such as real-time data processing, control and communication, ensuring the reliable operation and mission success in aviation system. Components of embedded system. Components of embedded system includes CPU, diagnostic port, ADC, DAC, sensor, actuator, human interfaces, memory, FPGA, like that. All of these components work together to enable the desired functionality of the embedded system. Processor. Any embedded system core component is the CPU. It determines how well the system works. There are three different processor types: 8-bit, 16-bit and 32-bit CPU. For embedded systems, smaller applications require fewer bits. Larger applications call for embedded system with larger bits. CPU consists of microcontroller or microprocessor or SoC, system on chip. ADC used as analog to digital converter, DAC used as digital to analog converter. Human interfaces is a component which is used to display the output to the user. Diagnostic port is used to check if everything is working fine or any need services. Now we will see about basics of PIC microcontroller. What is microcontroller? Microcontroller is an integrated circuit which is capable of being programmed to perform specific tasks. Unlike microprocessor, microcontroller has all components integrated in a single chip, and also it is cheaper than microprocessor. It is less flexible and requires less design complexity. In this project, we are used PIC16F877A microcontroller. Now we will see about some specifications of PIC microcontroller. PIC stands for Peripheral Interface Microcontroller. It has 5 ports, port A to port E. Port A have 6 pins, port B 8 pins, port C have 8 pins, port D have 8 pins, port E have 3 pins. It is very easy to use flash memory technology so that we can write or erase until 1000 times. It can also support SPI protocol, support serial communication, for it has 2-pin transmitter and a receiver. It also supports 3 timer: timer 0, timer 1, timer 2. Now we see about what are the software we can use to implement this project. Um, Pixim Lab and MP Lab X IDE, XE9 compiler used for compile purpose, and also Pic Genius PIC 16F877A microcontroller board.
Hello everyone, my name is Bartram. I'm going to explain about the software components and PIC architecture used in this project. So the first software component which we are going to see is MPLab X IDE. MPLab is a development environment for the development of embedded applications on PIC controllers, and it is developed by Microchip technology. So MPLab X is the latest version of MPLab IDE. MPLab X supports editing, debugging, and programming of microchip 8-bit, 16-bit, and 32-bit PIC controllers. So MPLab XC8 is a C compiler for 8-bit PIC and AVR devices. So next software component which we are going to use is PICSIM simulator. So PICSIM simulator is a real-time simulation tool for development of both integrated with MPLab X or AVR GDB debugger. Uh, Pixim Lab supports Pixim microcontrollers and some other SIM AVR microcontrollers. So Pixim supports many interfaces which can be connected to the Pixim Lab. So for LEDs can be connected and can be used for seeing the simple outputs, and Ethernet shield W5500 for internet connection, and color graphic display ILI 9340 with touchscreen can also be connected for complex applications. Now coming to PIC 16F877 architecture, so it consists of two buses. One is data bus, address bus, which differentiates the address and the data lines. So PIC 16F877A has 5 ports: port A which is 8 pins, uh, port A 6 pins, port B 8 pins, port C 8 pins, port D 8 pins, and port E 3 pins. And PIC 16F877A support 3 timers: timer 0 with 8-bit, timer 1 with 16-bit, timer 2 with 8-bit. Then CPU is the main important aspect of any microcontroller. So in the CPU of PIC 16F777A, it has ALU, a memory unit, and a control unit accumulator which performs arithmetic and logic operations. Mm, And the important aspect of embedded system is analog to digital converter. It has in this PIC 16F8, it is controlled by ADC 0N0 and ADC 0N1, and it has 10-bit A to D converter as shown in the figure. So PIC 16F777A has three types of memory. One is program flash for storing the program memory, which is 8 kilobytes, and data memory 368 bytes, and data EEPROM 26 bytes. Then we are going to see about the port B in PIC 16F877A. So port B is a bidirectional port. Similarly, port D similar function with port B. It is also a bidirectional input-output port. It's 8-bit wide. Port B as a data direction register TRIS B, and port D as similarly as a data direction register TRIS D, which is 8-bit wide. So the this register is used for selecting the input or output for a particular port as shown in the figure. Then we are going to see about timers in the PIC 16F877A. So the in timer 2, it has two 8-bit registers, that is TMR2 and PR2. TMR2 is used to store the initial count value, and PR2 is used to show is used to store the ending count value. Both the registers are readable and writable. Now, timer 2 has a prescaler and postscaler, which is used to make additional divisions in the frequency clock source. It is connected to internal clock of 4 MHz, and the interrupt is generated on overflow. So next is we are going to see about the prescaler and postscaler working. The prescaler divides the input frequencies to 1:1 or 1:4 or 1:16 scaling before it goes to the TMR2 register. So after it reaches TMR2 and PR2 register, it goes to post scaling, which divides the output frequency 1:1 to 1:16 frequency ranges. So the timer 2 control register, it controls the operation of timer 2. The first two bits 0 and 1 is timer 2, which controls the prescaler of the timer. So if 0 0 is input of first two bits, then its prescaler is 1 0 1 means prescaler is 4, 1 0 means prescaler 16, and 1 1 means prescaler 16. Then the second bit tcon 2, which controls the on and off of the t2 con register. So 1 means timer 2 is on, 0 means timer 2 is off. The next is the last for 3 bits, the last 4 bits, which controls the output post scalar bits. So if 0 0 is the input, 1:1 post scalar, 0 0 0 1 1 post scalar, and so on. If all ones are given, 1:16 post scale is done. So this is the explanation of timer to bits. Then a block diagram shows the working of the timer to register. As shown in the figure, clock, the oscillation frequency of divided by 4 is given as input, and the prescaler is done before the timer to register, and it is going to the comparator. After comparing with the PR2 register, it is going to the post scaler. Then it is monitored by a TMR2 IF. IF means interrupt flag. If interrupt is generated, then the execution of the program changes, which I'll be explaining in the next slide.
Here the code is already done. Let us select the code. Here RB4 is switch 5, RB3 is switch 4, RB4 is switch 5, and RB5 is switch 6. Now press key 5 to power on the washing machine. Let us press key 5. Now we can select. Now we should select the washing programs as per our requirements. We can select our washing programs as per our requirements. Like to scroll through these options, we have to press switch 4. When switch 4 is pressed, the option gets incremented. To select a particular program, long press switch 4 for 10 seconds. After that, we can select the water level. You can also scroll through the options using the switch 4. Now if you have to select water level, again long press switch 4 for 10 seconds. Now we can either start or stop the program. If start is switch 5 is pressed, start option is pressed, the program gets executed. Now as you can see, the fan is on and the timer is decrementing. Let us wait until the timer goes to 0, until the process ends. As you can see, the program is completed. You can remove the clothes.